Let's talk about the method of undetermined coefficients, that is the superposition approach, for exponential functions. Let's look at how to solve non-homogeneous equations like y double prime plus p of t y prime plus q of t y equals g of t. So again, notice this is not 0. If it were 0, it would be a homogeneous equation. The general solution of this differential equation would be y equals y sub p plus y sub h. Y sub p is one particular solution to the differential equation, and y sub h is the general solution to the corresponding homogeneous differential equation y double prime plus p of ty prime plus q of ty equals 0. So again, notice this differential equation has a 0 on the right side. It's homogeneous. We will focus on non-homogeneous linear second-order equations with constant coefficients. So the p of t and the q of t, those will just be constants. For example, let's say we have an equation of this form, y double prime plus p of ty prime plus q of ty equals g of t, where g of t is an exponential function. Here's an example. Find a particular solution of y double prime plus 4y prime plus 3y equals 96 e to the 5t. And again, this is an exponential function on the right side. The derivatives are multiples of e to the 5t because we've got y double prime, we've got y prime, we've got y. You add those up and you get a multiple of e to the 5t, so we suspect that y sub p, a particular solution, is a multiple of e to the 5t. So our first guess is going to be y sub p equals, let's say, a e to the 5t. So y equals a e to the 5t. The derivative of y prime is 5 a e to the 5t, and the second derivative is y double prime equals 25 a e to the 5t. Why do I calculate those? So that we can plug them into the differential equation. So when we plug in y double prime, when we plug in y, when we plug in y prime, we end up with y double prime plus 4y prime plus 3y equals e to the 5t. In other words, 25a e to the 5t plus 4 times 5a e to the 5t plus 3 times a e to the 5t, and that equals 96 e to the 5t. Add up the left side, and we end up with 48a e to the 5t equals 96 e to the 5t. In other words, 48a equals 96, so that a equals 2. Again, our initial guess was a e to the 5t, and since a equals 2, that means our particular solution to this differential equation is y equals 2 e to the 5t. So we found a particular solution. Now let's find a general solution of this differential equation. The general solution of this differential equation will be y equals y sub p plus y sub h, where y sub p is one particular solution to the differential equation, we just found that, and y sub h is a general solution to the corresponding homogeneous differential equation, y double prime plus 4y prime plus 3y equals 0. So we need to find a solution to this. We've seen how to solve something like this. You get r squared plus 4r plus 3 equals 0. That factors as r plus 1, r plus 3 equals 0. In other words, r plus 1 equals 0 or r plus 3 equals 0. That means r equals negative 1 or r equals negative 3. This implies, as we've seen before, that y equals e to the negative t, that's r equals negative 1, and y equals e to the negative 3t, that corresponds to r equals negative 3, are solutions. So the general solution to this homogeneous equation is going to be any linear combination of those. It's going to be y equals c1 e to the negative t plus c2 e to the negative 3t. And the general solution to the non-homogeneous differential equation is going to be, again, that's going to be y sub p plus y sub h. Here's your y sub p, 2 e to the 5t, and there's y sub h, c1 e to the negative t plus c2 e to the negative 3t. Okay, that's our general solution to the non-homogeneous differential equation. So now that we've found that, let's solve the initial value problem. Same differential equation, y double prime plus 3y prime plus 4y equals 96 e to the 5t, y of 0 equals 10, y prime of 0 equals 8. So we've seen that the general solution to this differential equation is of this form. Y equals 2 e to the 5t plus c1 e to the negative t plus c2 e to the negative 3t. We know what y of 0 is, so let's plug in 0. We get y of 0 equals 2 times e to the 5 times 0 plus c1 e to the negative 0 plus c2 e to the negative 3 times 0. That simplifies to 10 because, again, y of 0 equals 10. We were told that at the top. equals 2 plus c1 plus c2. Subtracting 2 from both sides, we get c1 plus c2 equals 8. Okay, that's one equation. That's great. We obtain the other equation by considering the fact that y prime of 0 equals 8. So let's find y prime. Here's our general equation for y, 2e to the 5t plus c1 e to the negative t plus c2 e to the negative 3t. Let's take the derivative of both sides. We get y prime equals 2 times 5e to the 5t minus c1 e to the negative t. Again, it's minus because we're taking the derivative. Minus 3c2 e to the negative 3t, because the derivative of e to the negative 3t is negative 3 e to the negative 3t. Plug in 0, because we know what y prime of 0 is, and we get 2 times 5 e to the 5 times 0 minus c1 e to the negative 0 minus 3c2 e to the negative 3 times 0. In other words, 8, since y prime of 0 equals 8, equals 10 minus c1 minus 3c2. If we subtract 10 from both sides, we get negative 2 equals negative c1 minus 3c2. Or in other words, negative c1 minus 3c2 equals negative 2. So here again was the general form of the equation. We need a solution to this system of equations that we saw on the previous page. And it turns out that the solution is c1 equals 11, c2 equals negative 3. So that means the solution to the initial value problem is y equals 2e to the 5t plus 11e to the negative t minus 3e to the negative 3t, because those are the values of c1 and c2.